In this video, we're going to take a look at another example where we use exponent laws to write our equation a little bit differently in order to solve. So we are trying to solve 4 to the power of x minus 9 times 2 to the power of x plus 1 plus 32 equals 0. Looking at this equation, I notice that the x appears in 2 different spots. So solving by rearranging is not really a good method here, which would lead us to either solve by factoring or quadratic formula. So right now, if I want to try to solve by factoring or quadratic formula, this isn't really in a format that's going to work for that. What I would like to do, if we are going to try to factor or use quadratic formula, is try to take all the powers, so all the ones that have exponents, and see if I can write them with the same base. So I have 4 to the x, and I have 2 to the x plus 1. Those are the parts that have exponents. So I know that 4 is the same as 2 squared. So I'm going to rewrite this as 2 to the power of 2, and then that is to the power of x. Take away 9. Now this does have a base of 2, which is good, but I would like to split this up, right? I would like to try to break that up into 2 to the x times 2 to the 1. That is something that we have tried doing before. So this is going to become 2 to the x times 2 to the 1. And then we're going to add 32. I could write that as a power of 2, but I don't need to because it doesn't have an exponent. I only do it with the things that have exponents. Okay, I've got 2 to the x, and here I have a 2, and there is an x. This one here, when I have one base with 2 powers, it doesn't really matter which one is closer to the base. So I could rewrite that as 2 to the x to the power of 2, right? Whether I do 2 to the 2 to the x or 2 to the x to the 2, it doesn't really matter. On my middle one, 2 to the power of 1 is 2. And if I try to bring that to the front, there's a 9 there. So I would multiply the 2 and the 9 to get 18. So minus 18 times 2 to the x plus 32 equals 0. Now from here, you've got choices. You could try to factor it as is. I would maybe take out those 2 to the power of x's and do a little bit of variable replacement and put in another letter like a. So I'm going to let a equal 2 to the power of x. That is going to create a squared minus 18a plus 32 equals 0. And then we are going to try to factor that. So we are going to look for 2 numbers that would add to negative 18a that also multiply to the first and the last, so 32a squared. Things that make 32 would be 1 times 32. I cannot make an 18 out of that. 2 times 16. I could make an 18 out of a 2 and a 16. However, in order to be negative 18, it would have to be negative 2 and negative 16. Okay, so I'm going to replace that middle term with negative 2x minus 16x. So I get a squared minus 2a minus 16a plus 32a. Nope, there's no a, it's just a 32 equals 0. I'm going to group the first 2, last 2. First 2 both have an a, and then I would have to multiply by a minus 2 to get that expression back. I take the sign from the middle. 16a and 32, they divide by a lot of numbers. They divide by 2, they divide by 4, they divide by 8, but they also divide by 16. And I want to take the largest number I can, and then I'd have to multiply negative 16 by a and negative 2 to get that expression back. So this is going to give me a minus 2, that's the bracket that they have in common, and then a minus 16. Okay, I need to take that and put 2 to the x back in. Now I could solve first for a and then put the 2 to the x in, or I could put the 2 to the x in and then solve. It really doesn't matter. I actually think I might keep solving. So we're gonna go way up over on the other side where we have some space. So I have a minus 2, a minus 16 equals 0. So that means one of those two brackets has to be 0. So either a minus 2 equals 0 or a minus 16 equals 0. I'm going to add 2 to both sides to get a equals 2, and then add 16 to both sides to get a equals 16. Okay, at this point we have solved as far as we can with the a, so I need to put the 2 to the power of x back in. So I have 2 to the power of x equals 2, and 2 to the power of x equals 16. Now, in order to solve, I have two choices. I can either take this base of 2 to the other side and do a log, or I can try to write them as powers with the same base and then compare their exponents. For this first one, they already have the same base, so I think that's the method I'm going to use. This 2 would be a secret 2 to the power of 1. So if I compare those exponents, they have the same base, so those exponents should be equal. That means that x would equal 1. For the other one, like I said, we have choices. I can either write this as a power of 2, or I could do log base 2 of 16. I think I'm going to write it as a power of 2 just because it does work out nicely. This is 2 to the power of 5. So x is going to end up equaling 5, right? They have the same base, they're equal, so their exponents must be equal. So x equals 5. That means this has two solutions, right? X equals 1 and x equals 5. Well, I think my marker is running out. All right, I will see you in the next video to do the next question.